Welcome to the Deep Dive. We're the show that takes, well, a whole stack of sources, research articles, and we pull out the key nuggets of knowledge for you.
That's right.
So today, imagine trying to guide thousands, maybe tens of thousands of cars through a huge city, efficiently.
Okay.
What happens if a major highway just suddenly gets jammed?
Hmm.
Or a bridge is closed completely? How do you actually keep that traffic flowing?
Yeah, how do you stop gridlock, make sure everyone gets where they need to go without massive delays?
Exactly.
It's a huge logistical puzzle in any city, right? Needs constant watching, smart rerouting. And, well, what we're digging into today, Fortinet Secure SD-WAN, it's designed to tackle pretty much that exact challenge,
Oh, okay.
but for network traffic, on a global scale.
That's a fantastic analogy. So yes, today we are taking a deep dive into Fortinet Secure SD-WAN. We're going to pull apart the key ideas behind this really powerful networking solution. And we're drawing our insights straight from the kind of training materials network engineers use. Serious stuff.
Yeah, the FCSS exam prep, to be specific. And our mission here is, well, it's to turn what can seem like really dense technical jargon into something you can actually understand and maybe even use.
Right.
You should walk away with a clearer picture of how this tech helps businesses manage their networks, keep traffic flowing the best way possible, and honestly simplify some pretty complex setups.
So like a shortcut to understanding the main parts. Design, deployment.
Exactly. Design, deploying, monitoring, and troubleshooting when things go wrong.
Yeah.
The whole life cycle.
Okay, let's get into it then. If we're building this smart city traffic system from scratch, what are the absolute must-haves for an SD-WAN setup to even, well, work?
What's the foundation?
Yeah, what's the very first step to get those network roads working?
Well, the core requirement, it's actually surprisingly straightforward. For a basic SD-WAN setup to be operational, you absolutely need two things configured: SD-WAN rules, and you need to define the members.
Rules and members, got it.
Think of the members like the individual roads, the lanes carrying the traffic, and the SD-WAN rules. They're like the fundamental traffic laws. They tell the network how to use those roads. These members, they're the physical interfaces, or maybe logical ones, that are part of this SD-WAN fabric.
So defining the rules of the road and identifying the actual roads makes sense. So what does it take to, successfully bring one of those roads, an SD-WAN member, online, ready for traffic?
Okay, so for a member deployment, two key things must be done. First, you have to assign it to an SD-WAN zone.
The zone.
Yeah, think of it like grouping roads into specific traffic districts. Helps manage things consistently.
Right.
Second, and this is crucial, you must enable health checks. These are absolutely vital. They constantly monitor the quality of that specific link, that road, making sure it's actually fit to carry traffic.
So it's like checking for plot holes or congestion in real time.
Pretty much, yeah. And what's interesting here is, the more advanced stuff like IPsec encryption for security or specific firewall rules, those are configured separately. They aren't mandatory just to get the member up and running initially. Shows you build it in layers, foundations first.
Right, that makes sense. Now here's where I think it gets really interesting. How does SD-WAN intelligently decide where traffic goes? It's not just blindly sending packets down a pipe.
No, definitely not.
We're kind of used to thinking about user traffic, me browsing the web or connecting to a VPN. But what about traffic coming from the network device itself? Like, our city's emergency services needing to communicate. They can't get stuck in rush hour.
Exactly. And that's where SD-WAN local out rules come in. This is quite fascinating, actually. These rules specifically handle traffic that originates from the FortiGate device itself.
The main network box.
Right, the core device. Or traffic that's heading to its own management and system services.
Such as?
Well, crucial stuff like communications with FortiManager, which we'll talk about, for central management, or FortiGate-generated services, things like DNS lookups it does itself, or NTP for time syncing.
Okay, so its own operational traffic.
Precisely. And this isn't just a minor detail, it's a critical design choice. By having these local out rules, Fortinet makes sure the network's own vital communications, its emergency services, its connection to the central brain, always have priority. They get their own optimized paths, ensuring the network itself stays stable and manageable no matter what else is happening.
So that's different from my normal web browsing traffic.
Totally different. Your typical user traffic, say VPN to VPN between sites, or you going out to the internet, that's generally handled by different SD-WAN rules.
That is a huge distinction. Okay, so how does SD-WAN know which path is actually best? It's not just steering, it's smart steering based on performance. How does our smart city system make those real-time calls about which road is fastest right now?
Yeah, good question. It leans heavily on performance SLAs,
Yeah, just let me
surface
get through
level
this. Yeah.
agreements.
Okay, great.
These are absolutely fundamental for making those intelligent forwarding decisions. Think of it like a really smart GPS that's constantly checking real-time road conditions.
Huh.
These SLAs, they involve setting specific thresholds for network link quality metrics. The big three are latency, jitter, and packet loss.
Okay, latency, jitter, packet loss.
Yeah.
Now, for someone maybe newer to networking, what do those actually mean in terms of like real-world impact? How do they affect my experience?
Good way to put it. Let's stick with the car analogy.
Okay.
Latency is basically the delay, how long it takes a car or your data packet to get from A to B. High latency, that means slow website loading, lag in games, that kind of thing.
Gotcha. Slow.
Low jitter. That's about the consistency of the delay. Imagine a road where traffic suddenly speeds up, then slams on the brakes and speeds up again, unpredictably. That's jitter.
Oh,
For things like voice calls or video conferencing, jitter makes it sound choppy, bumpy, really unpleasant.
right. That annoying robotic sound sometimes.
And it could be jitter, yeah. And finally, packet loss. This is when cars or data packets literally just disappear off the road. They never arrive.
Oh, that sounds bad.
It is. It results in missing information, maybe frozen video screens, dropped calls entirely. These three, latency, jitter, packet loss, they're like the vital signs of your network link.
And SD-WAN is constantly checking these vital signs.
Constantly. Dynamically evaluating them against the thresholds you set in the SLA to pick the best path using live data.
That's incredibly clear.
Yeah.
So if I'm a network admin and I need to see how things are looking, how are my links performing against these SLAs? Is there a quick check?
Absolutely. For the admins out there, a really useful diagnostic tool is a CLI command. It's diagnose SysWAN member.
Diagnosis one member.
Yep. Run that command, and it'll show you the current status of your SD-WAN members, their health, and crucially, the results of those SLA checks.
Like an instant performance report for every road segment.
Exactly. Super handy for troubleshooting.
Okay, so we've got the basics down, how it intelligently steers traffic based on real-time conditions. But what about really big networks? You mentioned global scale.
Right.
When you're talking hundreds, maybe thousands of devices, different sites all over the place, managing each one manually, that's just not feasible.
No way. It's impossible.
So how does Fortinet handle that scaling challenge? How does our smart city grow into a smart mega region?
This is where FortiManager steps in. Think of it as the central brain, the main city planning department for these large-scale SD-WAN deployments.
That's central control.
Exactly. And one of the biggest advantages, probably main advantage, of using something called the SD-WAN overlay template within FortiManager is its power to automate the configuration and deployment.
Automate what specifically?
SD-WAN policies, the rules we talked about, and also the VPN connections between all the sites across potentially hundreds or thousands of devices.
Wow.
It massively simplifies rolling out these large networks and, importantly, keeps things consistent. It's kind of like rolling out a new set of traffic laws across the entire city or mega region with, well, maybe not one button, but close.
That automation makes sense for scale. But what about keeping things consistent across different regions? Maybe one region has slightly different needs, different local regulations or ISP setups, but you still want that overarching, unified approach for the whole network.
That's a really good point. How do you handle regional variations without messing up the whole template?
Yeah.
FortiManager has a clever solution for that. Overlay templates with meta fields.
Meta fields.
Yeah. This is where the real flexibility comes in. These templates let you reuse the main configuration, blocks the core traffic laws, if you will, but they have customizable fields within them.
Ah, like variables.
Exactly like variables. So if one region needs, say, a specific local DNS server address or a different bandwidth setting, you define that using a meta field for that region's devices.
Okay.
But the rest of the core configuration, the main SD-WAN rules and security posture, stays consistent because it's from the master template.
So you get both consistency and local customization.
Precisely. It lets you adapt to those regional differences without having to create entirely separate brand new configurations for each one. This avoids what we call configuration drift, where things slowly become inconsistent over time.
And makes ongoing management much simpler, I bet.
Hugely simpler. It's like having that master blueprint for all your city districts, but with specific marked areas where local adjustments are allowed and expected.
Okay, great. So we've covered setting up our smart city network, how it smartly directs traffic, and how the central planning department, FortiManager, handles growth and regional differences.
Mm-hmm.
But networks, well, just like real cities, they aren't always perfect, right? Things go wrong. What happens when that best highway, the preferred path, suddenly floods? Or maybe all the good paths become unavailable for some reason.
Adversity strikes. Yeah, it's a critical scenario to consider. What happens if all the SD-WAN members that are configured within a specific rule fail their SLA checks?
So every available link for that type of traffic is performing poorly, below the thresholds.
Right. Every option is bad according to the rules you set.
Yeah.
In that situation, the outcome is usually one of two things. Either the session, that specific traffic flow, might be dropped entirely.
Just stopped.
Potentially, yes.
Yeah.
Or it might fall back to using what's called an implicit rule, which often means using the system's default route, like a last resort path out.
Okay.
What's important to understand here is what doesn't happen. The FortiGate device, it doesn't just hold that traffic indefinitely waiting for a link to get better.
It doesn't buffer it forever.
No. And it also doesn't automatically trigger, say, an active-passive HA failover where the whole device fails over to a backup just because one specific rules members failed their SLAs.
Ah, okay. That's a specific nuance.
It is. It shows the system is designed to adapt or fail fast for that specific traffic rather than potentially creating a bigger bottleneck by holding on to it indefinitely. It highlights the resilience mechanisms, but also, the defined limits in a complete failure event for a given rule.
That leads nicely into another scaling topic, especially for these huge networks. For really large VPN deployments, you mentioned hub and spoke models earlier. That sounds like all traffic having to go through one central point, like a downtown interchange.
It often is, yeah. The traditional model, every suburb-to-suburb trip has to go via downtown.
Which sounds inefficient if you have lots of suburbs talking to each other. Is there a better way?
There is. And this is where another advanced feature called AD-VPN comes in. That stands for Auto Discovery VPN.
Auto Discovery VPN.
Okay, it's a real game changer for large VPN setups. Remember the hub and spoke model? Hub is downtown, spokes are the suburbs.
Right.
AD-VPN allows the spokes think individual branch offices or remote sites to establish dynamic, direct tunnels with each other on demand.
So suburb to suburb directly, skipping downtown.
Exactly. It's like enabling those cars to discover and use direct shortcuts or bypasses between suburbs whenever they need to communicate without routing everything through the central hub.
That must make things way faster and less bottlenecked at the hub.
Hugely. It significantly improves scalability in large SD-WAN deployments because it reduces the load on that central hub device, and it boosts efficiency.
And the auto discovery part, does that mean you don't have to manually set up every single connection?
That's the beauty of it. It happens automatically based on traffic patterns without needing an administrator to manually configure every single possible spoke-to-spoke tunnel beforehand. Imagine doing that for hundreds of sites.
Nightmare.
AD-VPN drastically simplifies managing these potentially very complex VPN mesh networks.
Okay.
It really is.
Okay.
This deep dive hopefully gives you that shortcut to being, well, pretty well informed on SD-WAN principles.
So as we wrap up, we always like to leave you with something to chew on, a provocative thought.
Okay.
Given how critical this dynamic traffic steering and centralized management clearly are for today's networks, what kind of surprising new applications or maybe network efficiencies might pop up as these SD-WAN technologies keep evolving, especially as they start integrating more with other emerging tech, like, say, AI?
Ooh, interesting question.
What might that fully automated, maybe even self-healing network of the future really look like? Building on these kinds of foundational principles we've talked about today, something to think about.